Hi, this is Stephen Carson coming at you from St. Louis, Missouri, in these United States. Today's the day where my ambition probably has finally outstripped my competency, trying to do a crash course in Aristotelian um physics, I guess you could say, his understanding of um, matter and form and motion. And we're going to do it in like 60 minutes. Here we go. Support for the show is gratefully received on Subscribestar, links in the YouTube video description. If you, most people support at $5 a month, and it really helps. All right. Okay, so let me position this. First of all, there's a playlist in the video description. It includes an older video we did about the Industrial Revolution of the Middle Ages. Thought it kind of fit nicely with this series. And then the rest of the playlist will be this series. So I've only done one so far, which is the first 3 chapters of this book, Foundations of Modern Science in the Middle Ages by Edward Grant. What did we cover before? So laid some groundwork with the state of science and natural philosophy in the ancient world during the first 6 centuries after Christ. And then we got into our real story, which begins about 1,000 years ago as they started to translate into Latin some of the works of the important thinkers, Aristotle in particular, but also people who were other ancient Greek thinkers and people who were making commentary on Aristotle, and spent some time going through that because those translations were really key to kicking off the beginning of thinking about science. And then we also covered the medieval university, the nature of that university, the trivium, the quadrivium, the 3 philosophies, and how the university became a institutionalization of science. So there had been some systematic thinking, as we're going to spend this whole show talking about. There had been some systematic thinking trying to understand the world. And other literate, thoughtful people had read and commented on that thinking, and there was a bit of a tradition of thought. But I don't think it had ever been institutionalized in the way that it was in the medieval university, where, yeah, Aristotle is Rad Liber Randian now. I actually don't know that much about Rand. All I remember is A is not A or something. Which makes a lot of sense now that I've been learning about Aristotle, as we'll see. But anyway, thanks for your comment, Froggy. Froggy. What was I saying? So, yeah, the universities, the medieval university became a way to keep that conversation going about Aristotelianism, Aristotelian natural philosophy. Remember, natural philosophy is what we now call science. It's just the philosophy of the natural, thinking systematically about the natural world. It's a long way of saying it, right? But both natural philosophy and science refer to the same thing, as far as I can tell. We just don't call it natural philosophy anymore for some reason. And so Aristotle really is key. And I was even thinking of like skipping this chapter, and then I'm like, wait a second. The medieval thinkers and scientists, early scientists, well, the scientists all along, really, throughout the Middle Ages and even in early modern science, saw Aristotle as really key. I better give him his due weight. So we're only going to cover one chapter today, but it's a lot of conceptual work. I've even got some images to try to help us think about this stuff. Okay, so let's go. Let's see. I am probably not on the right thing right now, am I? Oh, I am. Good, good. Okay, here we go. So let's start with the book, and then I'll be dropping into some images soon. So what the Middle Ages inherited from Aristotle. Yeah, so Aristotle's natural books, his books on this topic, formed the basis of natural philosophy in the universities, and the way in which medieval scholars understood the structure and operations of the cosmos must be sought in those books. By his use of assumptions, demonstrated principles, and seemingly self-evident principles, Aristotle imposed a strong sense of order and coherence on an otherwise bewildering world. Aristotle's medieval disciples, who formed the class of natural philosophers during the late Middle Ages, would eventually extend Aristotle's principles to activities and problems beyond anything that the philosopher himself had considered. In fact, I've got a great example that comes from the late 19th century, where I think once I've given you a taste of sort of how Aristotle breaks things down, you'll see how much this is just straight up Aristotelian, an Aristotelian approach to something that extends Aristotle, an Aristotelian approach into a new area. But anyway, we'll get to that. I want you to have some context first. But anyway, something from my own field. So let's get into it. How did Aristotle, some of these things are assumptions, some of these things are him, as usual, categorizing, right? That he's the great categorizer. Aristotle was convinced that the world he sought to understand was eternal, without beginning or end. And it seems like he grabbed onto that because he didn't like the idea of trying to figure out how it all began. It says the idea that matter could have a beginning seemed impossible to the ancient Greeks. For if one were to arrive at some alleged pristine matter, it would inevitably lead to the question of what caused it, and so on. So they were concerned about like an infinite regress, and so they just said, yeah, this stuff's just always been here. So immediately we see a conflict with the monotheistic religions, because the eternity of the world sets him in opposition to the theologians of the great monotheistic religions of Judaism, Christianity, and Islam. And it says, this is kind of jumping ahead to the next chapter, which we'll deal with next time, how Aristotle was received by the medieval world. But give you a teaser here. Of all the issues that involved natural philosophy and theology during the 13th century in Western Europe, theologians regarded the eternity of the world as the most difficult and threatening for their faith. But if his insistence on the eternal world was kind of suspect, he was in agreement with the scriptures on the uniqueness of the world. He regarded our world as unique, a large finite sphere beyond which nothing could exist. All existent matter is contained in our world with none left over. Okay, so now we start to really get into thinking about, I don't know what to call this, fundamental conceptualization of matter. Without body, neither place nor void nor time could exist beyond the world, because the definitions of place, void, and time all depended on the existence of body, or Aristotle's definition of body. For Aristotle, the proper place of a body was always the innermost surface of another immediately surrounding body that was in direct contact with the contained body. Thus, a place is defined as something in which body must be present. Without the existence of a body beyond our world, no place could exist. Similarly, a void is something in which the existence of a body is possible, though not actual. If no body is possible, no vacuum is possible. Finally, time for Aristotle is the measure of motion, related to motion. Without body, there can be no motion, and therefore no time. So, therefore, all existence lay within our cosmos and nothing beyond. The nothing, in this sense, is not to be construed as a vacuum, which is an absence of something that could be there, right? But is best characterized as a total privation of being. So, within the cosmos, within our world, I don't know what to call it. We might say our dimension, I don't know. Within our material world, there can be presence and absence of physical bodies, place, motion, time. Outside of that, there's just nothing. There aren't things. There's an absence and presence, even. So, perhaps the most momentous decision that Aristotle made about the eternal physical world was to divide it into two radically different parts. The terrestrial, which extended from the center of the Earth to the lunar sphere. So we'll get to spheres, but just picture the moon outlining a circle around the Earth, and that circle being the one part of a sphere, right? Outlining the dimensions of a sphere, and from that sphere outlined by the orbit of the Earth down to the center of the Earth, that is the sublunar sphere or the terrestrial sphere. Okay, so that's one part, the terrestrial. The other is the celestial, which is everything from the moon to the fixed stars. We'll get to the fixed stars bit in a moment. So in the terrestrial region, observation and experience made it obvious that change was incessant, whereas in the celestial region, change was virtually non-existent. Astronomical observations inherited from the past had convinced Aristotle that no changes had ever been detected in the heavens. And so he inferred that changes did not and could not occur there. So you have a changeable earthly sphere, and you have a unchanging heavens, right? The earth and the heavens. So the rest of this chapter divides into two, the terrestrial region and the celestial region. So let's start with the terrestrial region, the realm of incessant change. So much of Aristotle's natural philosophy is an attempt to identify and explicate the principles of change in the terrestrial region, principles that shaped medieval interpretations of the processes that make the world what it is. So he's going to explain how the development of matter is to be imagined, how it is differentiated into four basic elements: earth, water, air, and fire, that form the building blocks of all material bodies in the terrestrial region. The underlying basis of all material bodies is prime matter, which I have to say sounds really cool. And if they haven't made a movie called Prime Matter, they should. Prime matter is real but has no independent existence. Well, we'll get to that. Okay. It was essential to assume the existence of some kind of substratum in which qualities and forms could inhere and produce sensible matter. Prime matter has no properties of its own, but is always associated with qualities that inhere in it and define it. So, which properties or qualities would raise prime matter to a higher existent level, say to the level of an element? Aristotle argued for two pairs of contrary or opposite qualities that could achieve this effect. Now, one theme you're going to pick up on here is that Aristotle's really into opposites. He wants to identify, this is the opposite of that, and you either have one or you have the other. You never have the both at the same time. You know, that's why I was saying A, not A, right? He keeps on bringing this up, and I think it leads into some errors. But anyway, just so you understand how he's thinking. So, two pairs of contrary qualities could achieve the effect of raising prime matter to the level of like an element. Hot and cold, that's one pair of opposites. And dry and moist, or dry and wet, that's the other pair of opposites. So hot and cold, dry and moist. Nothing could be simultaneously hot and cold at the same time, or dry and moist at the same time. So no single pair of opposite qualities could inhere in prime matter at the same time. But non-opposite combinations are possible and can produce elements. So hot and dry, cold and dry, hot and moist, cold and moist, right? And so now he is going to explain, and I have not figured out a slicker way to change things, so excuse me. It's going to be awkward as I go back and forth. Okay, where is it? There we go. Okay, sorry, and I'm on the wrong tab. There we go. Okay. see how that looks. A little pixelated, sorry. Okay, so you see dry, hot, cold, wet, and they combine together in this way in his view. Dry and hot give you fire. Hot and wet give you earth. Cold and wet give you water. And dry and cold give you air. All right? So thus were the four elements derived. But the actual perceptible, so these are elements, right? Similar to how we think of elements, so something that we don't necessarily perceive, but are the constituent elements that make up the things around us, right? So the perceptible bodies of the terrestrial region were not pure elements generally, but mixtures or compounds of two or more of them, and usually these were called mixed bodies in the Middle Ages. Okay, so you could have well, we'll get into it. So in Aristotle's natural philosophy or physics, every body is a composite of matter and form, where the matter serves as a substratum in which the form inheres. The form of a thing or a body is its essential defining characteristics, the properties that make it what it is. Every such body belongs to its own species and possesses the properties and characteristics, that is, the form of its species. If unimpeded, it will act in conformity with those properties. So he saw he saw each body in the world had its form, right? And it had the power to act in accordance with its natural capabilities. So so in this way, he allowed for secondary causation, where bodies were capable of acting on other bodies, that is, able to cause effects in other bodies. Aristotle believed that each effect was produced by four causes acting simultaneously. Now let me go to that. Okay. I'll read it and then go over the slide. So a material cause, the thing out of which something is made, a formal cause, or the basic structure to be imposed on something, an efficient cause, or the agent of an action, and the final cause, or the purpose for which the action is undertaken. So let me go over this, and also I have maybe another way to say it that's helpful. Okay, so the material cause, in the case of this table here, is wood. That is that out of which a thing is made, right? So the table's made out of wood. The formal cause is that into which a thing is made. And you can see there the formal cause is, the design or the template or the pattern for the thing. Okay. The efficient cause is that by which a thing is made. So in this case, we're going to take the wood, the material, we're going to form it into the pattern, the formal cause, by means of the efficient cause, in this case, carpentry tools, right? And all of this has a purpose, and that is the thing for which a thing is made, in this case, using the table to put food on and dine on, right? So that's its purpose. And a note on that final cause, the significance of that final cause for Aristotle. The goal or the end, the telos, the final cause of any given substance is the key to its understanding. This means that all nature is to be understood in terms of final causes or purposes, and this is known as a teleological explanation of reality. Things have a purpose for which they were made, and you can kind of, if you know that, then you can kind of reason backwards to a lot about that thing. Okay, so yeah, I'm going to go over it one more time. So the material is that out of which a thing is made. The formal is that into which a thing is made. The efficient is that by which a thing is made, and the final is that for which a thing is made, the purpose or the telos, right? The point of it. All right. Let's see, where am I? That's not what I wanted. Okay. Sorry, suddenly I'm having trouble finding my place. Okay, here we go. Right. Okay, so how does this come into his physics? The causes that produce a stone not only make it heavy, but if the stone is otherwise unimpeded, that heaviness confers upon it the capacity to fall naturally toward the center of the earth with a rectilinear motion, just aiming at the center of the earth, right? Similarly, the agents that produce fire confer lightness upon it, and therefore the capability of rising naturally upward, rectilinearly away from the center of the earth, whenever it is unhindered. So that's right. Okay. So that is the elements, the four causes, and now we're going to talk about four changes. Now, you'll notice that the number 4 keeps turning up. I have not studied philosophy, so I do not know what the deal is, and I'm wondering if there's anybody who can explain it, why Aristotle keeps doing things in 4s. But I notice a pattern here. So let's go to 4 changes. Here we go. Why is it showing? Okay, there we go. Okay, so Aristotle was also concerned about the kinds of changes that the 4 causes could produce, and he distinguished 4 kinds of changes. A substantial change, there we go, a substantial change, a change in substance, where one form supplants another in the underlying matter, as when fire reduces a log to ash. Okay, so the wood has a substantial change into ash, and that's a change in substance. Then there's a qualitative change, a change in quality, as when the color of a leaf is altered from green to brown in the same underlying matter. So it's not a let me be careful here. So a substantial change where one form supplants another in the underlying matter. A qualitative change where there's a quality change in the same underlying matter. So he's looking at that leaf and he's thinking, oh, it's basically the same thing. But it is having a change in some quality of it. In the case of a leaf, it's just changing a color. Then there's a change of quantity, as when a body grows or diminishes while otherwise retaining its identity. So the sapling growing into the tree is not going through a substantial change, like it's not becoming a different form. It's just becoming more or less of its form. Okay. And then finally, there's change of place, or what we'll call motion, when a body suffers change as it moves from one place to another. So that's a change in the body, but it isn't a substantial change, qualitative change, or quantitative change. It's just a change in location, right? But that's still a change. Okay, so change in substance, change in quality, change in quantity, change in place. So for Aristotle, of the 4 types of change, only the first and the 4th require explanation. Substantial change is the most basic form of change involving generation and corruption. For Aristotle, every substantial change implied that something had come into existence from the passing away of something else. So there was wood, that passed away, now we have ash, right? This coming to be and passing away of things was the basis of all change in the terrestrial region. It occurred in all substances composed of matter and form, which in the terrestrial region included all things. Forms or qualities were potentially replaceable by other forms that were their contraries. When this occurred, one substance was changed into another. So, for example, fire, which possessed the primary qualities of hotness and dryness, is changed into earth, which possesses the primary qualities of dryness and coldness. When the hotness in fire is replaced by coldness, its contrary quality or form. So he's working those opposites again, right? Fire is hot, in his view, hot and dry. When it goes to cold, the hot goes to its opposite cold, and you get cold and dry. Now you have earth. While one form is actualized in matter, its contrary is said to be in privation, but potentially capable of replacing it. Give me just a moment. Okay. Right. Let me say that again. Yeah. So while one form is actualized in matter, its contrary is said to be in privation, but potentially capable of replacing it. So remember, that was that idea that you could have a void, but that's a potential. A void only makes sense where it could be there. Sorry, I'm getting distracted because my wife is doing something and asking me questions by message. Okay. I think I've handled that. All right. Right. So fire would have be characterized by a privation of cold, but it could become cold. So it's like a void of cold, but it could become cold if it undergoes that change, right? Eventually, each potential form or quality must actually become what it is capable of becoming. Otherwise, a form would remain unactualized and nature would have produced it in vain. Yeah, it's really interesting. I think some people, yeah, anyway, Aristotle does seem to have a very purpose-oriented, design-oriented, you might say, view of nature, that things have a purpose. They're not there randomly by chance. They have a telos, a goal towards which they tend to go, if not interfered with. So yeah, it's I guess I'm just again noticing that teleological view, right? That end-oriented view or purpose-oriented view. So virtually all change, that is, generation and corruption, involves the possession of one and the exclusion of another of a pair of contrary forms of qualities. And then finally, the last of the four changes, motion, change of place, is the removal of a body from one location to another. And he has a whole doctrine of place. There's a narrow and a broad sense. In the narrow and most restrictive sense, it involves the specific place of a single body. The broad sense of place is where he conceives of the part of the world below the moon as a structured region divided into four concentric areas. Here we go with the four again, right? Each the natural place of an element, toward which that element would naturally move if unimpeded. So the outermost concentric ring, located just below the concave surface of the lunar sphere, is the natural place of fire. The next concentric ring is the place of air, the atmosphere, right? Toward which air rises if in the regions below, or toward which it would fall if for some reason it was located in the region of fire. So it's going to tend to either rise up to its place or fall down to its place. Similarly, below air is the ring of water, and below that is the sphere of our Earth, the center of which coincides with the geometric center of the universe. Okay, so I want to stop here and give an example from my own area of economics. And I'm drawing, let me share this. I might have talked about this before on a stream, but I think we're uniquely situated to appreciate this. This is from a speech on environmentalism by an Austrian who studied from Mises himself, George Reisman, who I've met, and a big Randian, by the way, for those into that. Uh, um, and he's drawing on Karl Manger, who was the founder of this Austrian School of Economics, who was very Aristotelian in his thinking, as I think you're about to see. And one of the aspects of Karl Manger's theory of economic goods is his recognition that what makes what would otherwise be mere things into economic goods is not the intrinsic properties, or not only the intrinsic properties of the things, but a man-made relationship between the physical properties of the things and the satisfaction of human needs or wants. And Manger describes how many prerequisites? 4. You should have seen that coming. All of which must be simultaneously present in order for a thing, a mere thing, to become an economic good. Or as he often puts it, for it to have goods character. What are these 4 things? Now, I think we'll find that as we read through this, I was almost trying to line it up. It's going to line up with these 4 causes if we sort of think through it. I might even try to do it live here. Unfortunately, he puts them in a different order than the 4 causes, but let's see if we can line it up. So Manger says you have to have all of these at once for a thing to be an economic good. A human need, such properties as render the thing capable of being brought into a causal connection with the satisfaction of this need. So some material properties, right? Number 2. 3, human knowledge of the causal connection. If we don't know that this thing will meet our need, then meet our human need, that doesn't really do us any good. And then 4, command of the thing sufficient to direct it to the satisfaction of the need. So let's use some counterexamples to think through this, how these 4 aspects must all be present. Let's say we have a human need. We would like iron ore because we know it's useful for various things, right? Iron ore, we have a human need. We want to make something out of iron. We want to make swords out of iron. The iron has the properties that help us, that we need to make it into a sword. We know, number 3, we know that iron has those properties to meet our need. So that's 3 of them. But it just so happens that the iron that we're considering as whether it's a good is on an asteroid that we cannot get a hold of. So it doesn't meet the 4th condition. We do not have command of the thing sufficient to direct it to the satisfaction of the need, right? So even though iron ore in an asteroid meets those first 3 conditions, we know it'd be great to help us solve our need, to meet our need. We can't get a hold of it. So it is not an economic good, and therefore, you can imagine what the next step is. There's no price. There's no sensible way to talk about there being a price, for example, for the iron in an asteroid that we cannot get a hold of. What would be the point of talking about the price of that iron? It would make no sense, right? Okay, so anyway, hopefully you can see. Manger is writing in, oh shoot, I should know. Give me a sec. Manger. He was writing, he died in, oh no, not that Karl Manger. Come on. There we go. Okay. Yeah, so his main books, works. Here we go. This was probably in Principles of Economics, first published in 1871. So here we are in relatively modern times, well after this period we're really looking at of around 700 to 1,000 years ago, the sort of the main Middle Ages there, and Manger is still using an Aristotelian approach to understand something that's really important to understand, right? I thought that was pretty cool. Okay, so let's see. Yeah, and I shared a link in the live chat to this paper, which I strongly recommend. Environmentalism, the Light of Monger and Mises. It is a very thought-provoking paper. Okay, I might change back to the text now. Let me see where I'm at. Right. Yeah, okay. So let's go back to the text. Awkward segue here. Here we go. Not too bad. All right, so back to Aristotle. The Earth being a sphere was a basic truth of Aristotle's system of the world. He offered observational evidence of its sphericity. The curved lines on the moon's surface during a lunar eclipse. Very good. Good point, Aristotle. Inferring rightly that these were cast by the shadow of a spherical Earth interposed between the sun and the moon. We have an eclipse, a full eclipse, coming on Monday here in the Americas, and my family is throwing plans together to get to where we can see totality, which we got to see when our children were a little bit younger, but won't be happening here for like 30 years more after this. So we're going to try to make it on Monday to see that eclipse. Right. So, well, sorry, I'm saying the wrong kind of eclipse. This is going to be the moon completely blocking the sun. Here, he's talking about a lunar eclipse, where we see the shadow of the Earth on the moon. Right. Let's see. He also noted that as one changed position on the Earth's surface, different stellar configurations came into view, indicating that the Earth possessed a spherical surface. And as another one, the sphericity of the Earth seemed further confirmed by the way bodies were observed to fall to the Earth's surface in non-parallel lines that met at the Earth's center. Okay. If all earthly bodies fell in this manner, they would cluster around the center of the world and form naturally into a sphere. So Aristotle's arguments that there was a spherical Earth were readily accepted. And as I explained last time, catch that first episode of this series if you didn't catch my little rant on the myth of the flat Earth, which was this thing that got spread in relatively recent times, just in the last 200 years or something. Maybe a little more than that, that in the Middle Ages, they thought the Earth was flat. I'm not going to say no one thought the Earth was flat, but no one who was educated thought the Earth was flat. And this idea that, Columbus knew the Earth was round and the church thought the Earth was flat and was telling him, no, you'll fall off the edge of the Earth. That's all just complete bonkers and lies, because they wanted to the people who spread these lies wanted to make the Middle Ages look bad. For their various reasons. Anyway, I give a little mini history of that in the first episode of this series. Okay, so what about the place of any particular body? Aristotle's doctrine of place is based upon a fundamental conviction that the world is a material plenum in which the existence of void space is impossible. From this it followed that the place of any individual thing in the sublunar region consisted of the matter that surrounded it. So what is a place? It's, I hold this, sorry, I can't see my screen. Okay, I hold this ball up. What is the place of this ball? Think of the stuff around the ball. It's between my fingers. There's air around it. That's the place of the ball. That's how we think about place. Okay. From this, right, yeah. So the place of a thing is the boundary of the containing body at which it is in contact with the contained body. The boundary or innermost surface of the container was also required to be motionless, which is a little confusing, and I'm not sure I follow where Aristotle was going with that, but the author here mentions that that was a qualification that posed serious problems in the history of Aristotle's doctrine of place. But anyway, I'm going to not go deep on that. So when a body met these conditions, it was presumed to be in its proper place, that is, in a place that it alone occupied, when it had this immobility idea. Okay, so I'm going to skip. Whoa, what happened? Okay, so now let's move on to motion in the sublunar world. Aristotle distinguished two kinds of motion, natural and violent, or unnatural. Natural and unnatural, but the unnatural he calls violent motion. The division of local motion into natural and violent, and the cluster of concepts, arguments, and physical assumptions associated with these two contrary motions formed the core of Aristotle's sublunar physics. So first, natural motion. The center of the earth, or more precisely, the geometric center of the universe, was the natural place of all heavenly bodies. They wanted to go to the center, right? Conversely, light bodies moved naturally upward in a straight line toward the lunar sphere, which was conceived as their natural place. So light bodies want to go up, heavy bodies want to go down. So let's apply these generalizations to the four elements. Whenever an elemental body composed primarily of earth was above its own natural place, whether that place was in water, air, or the fiery region above the air, it was deemed absolutely heavy because if unimpeded, if you didn't stop it, it would fall toward the earth's center. This isn't completely crazy stuff, right? If earth is, way up in the atmosphere, it's going to fall towards the earth. If it's in the water, it's going to, a heavy earth, right? It's going to sink down to the bottom of the water, right? It's going to go towards the earth's center. Fire was regarded as absolutely light. If unimpeded, fire would always rise upward from the regions below toward its natural place above air and below the lunar sphere. So I guess he's watching a fire and it's just up, up, up. It's, can't see where it stops, right? As for water and air, they were intermediate elements possessing only relative heaviness and lightness. When below its natural place somewhere within the earth, water would naturally rise. So I guess this is like springs, right? He's looking at a spring and he's saying, oh, the water wants to come up out of the earth to its place, right? But when above its natural place in air or fire, it would fall, right? So the rain falling from the sky. Air, however, would fall when in the natural place of fire, but rise when in the natural place of earth or water. And so I guess that would give him, I don't know if he conceived of it this way, but that would give him that notion of the atmosphere, which at the bottom is, earth and water are below it, and above it is that thing he calls the sphere of the place of fire. So the air doesn't want to keep going, and so our air stays. We retain an atmosphere, and it doesn't just float away. Oh, thanks, Blotto. He says, I study philosophy. I notice the force pattern, and it's real, but I don't know why. Thank you. I'm like, I was Googling around. I was like, no one's commented on the four thing. Anyway. Okay, so there you go. A paper in philosophy for someone to write. Okay, so these are the idealized natural behavior of each of the four elements, but elements did not exist in a naturally pristine state. In the real world, bodies were actually compounds made up of varying proportions of all four elements. Bodies that fell naturally towards the Earth's center did so because their predominant element was heavy. Those that rose naturally upward did so because they were determined by a light element. The greater the quantity of air or fire in an airy or fiery body, the greater would be its speed of ascent. That's how Aristotle conceived it. So back to his opposites. So we got the fours and we got the opposites, right? Those are his two patterns he keeps hitting. Three pairs of opposites played a significant role in Aristotle's interpretation of the structure of the terrestrial or sublunar world. First, there was the concave surface of the lunar sphere, and the opposite was the geometric center of the universe, or the center of the earth. Okay, so there's the center of the earth, and there's the concave surface of the lunar sphere. Then there's up and down, simple enough. And there's absolute lightness, fire, and absolute heaviness, earth. Okay? And so these opposites served as virtual boundary conditions for Aristotle's scattered account of the motion of bodies. The left-hand column tells us that an absolutely light body, fire, would naturally rise rectilinearly upward toward the lunar sphere. Whereas the right-hand column informs us that an absolutely heavy body would fall naturally down in a straight line toward the Earth's center. Okay, and I'm not going to keep going, but I'm mostly trying to give you a flavor here. I'm not going to touch every point. If you're finding this interesting, get the book and read it in detail. Okay, so Aristotle made his system heavily dependent on a variety of absolute contraries, choosing to avoid the relativistic comparisons of Plato and the atomists. So I guess he's reacting to the Platonists or something. Okay. To provide a causal explanation for natural motion, and as we shall see, for violent or unnatural motion as well, Aristotle invoked the general principle that every effect has a cause, and assumes that every animate and inanimate thing capable of motion is moved by something else that is itself in motion or at rest. Or to use the succinct medieval version of this principle, everything that is moved by another. Okay? The mover and the thing moved were always assumed to be distinct entities. And Aristotle assigned a particular agent for natural motion called the generator, generans, called the generator in the Middle Ages, as the primary cause of unobstructed natural motion. So the causative agent or generator was the thing that had originally produced the body actually in motion. For example, a fire produces another fire, as when a log is set ablaze, and confers on the new fire all the properties that belong to fire, one of which is the spontaneous ability to rise naturally when unimpeded. Similarly, whatever natural agent produces a stone confers upon it all of its essential properties, including the natural tendency to fall to earth when removed from its natural place. So, Aristotle concluded that velocity is directly proportional to the weight of the body in natural motion and inversely proportional to the resistance it meets, which is measured by the density of the medium through which it moves, and that the time of its motion is directly proportional to the resistance or density of the medium and inversely proportional to its weight. So, for example, the speed of a body could be doubled either by doubling its weight, but holding the medium constant, or halving the density or resistance of the medium and holding the weight of the body constant. Now, let's be clear. The point of all this is not to say that Aristotle got physics right. I think a number of people will probably be hearing this and going, this doesn't work out. You know, I think the point here, as I did with the example from economics, is to show how Aristotle's systematic way of thinking about things set a frame for making real progress. Not all of his, assumptions about natural philosophy, about science, turned out to be right, but his, I think, approach is has ended up continuing to be useful. Right, he sort of trains you. I think what happened is he trained the people who studied him in a way of thinking carefully through things, and he trained them to use opposites and sets of four, for whatever reason. But it's still, as that example about Good's character shows, it seems to pay off. So, okay, so violent or unnatural motion. Motions that are violent or unnatural occur when bodies are pushed out of or away from their natural places. The velocity of a body in violent motion is inversely proportional to its own resistive power, which is left undefined, and directly proportional to the motive power or applied force. I mean, you can kind of see how continuing to develop this way of thinking, we ended up with inertia and things like that, right? They might not have been exactly there in Aristotle, but he sort of set the trajectory to end up there. So for Aristotle, violent motion required a radically different causal explanation than did natural motion. The source of power that enabled a body to continue its motion after losing contact with its initial mover was far from obvious to Aristotle. So, for example, how did a stone continue its motion after losing contact with the hand of a child that threw it? Aristotle argued that the external medium, in this case air, right, the stone is traveling through air, was the source of continuous movement. So he believed that the original mover not only puts the stone in motion, but also activates the air simultaneously. So the first portion or unit of activated air pushes the stone and simultaneously activates the adjacent or second unit of air, which moves the stone a bit further, so on and so forth, until finally there's only enough, the force diminishes until it's only capable of activating the very next unit of air, but it's unable to communicate to it the power to move the body further, and then the stone starts to fall, right? The stone begins to fall with its natural downward motion. So by this mechanism, Aristotle employed the medium as both motive power, so the air is like carrying movement along, and also the air is causing resistance. He was convinced that the same medium had to function as a brake on the motion of the same body in order to prevent the impossible, which would be the occurrence of an infinite speed or an instantaneous motion. So he doesn't think we're going to have teleporters or transmats or whatever, right? Aristotle concluded that if a medium vanished entirely, leaving a vacuum, motion would be instantaneous or beyond any ratio, as he put it. And so the absurdity of an infinite speed was one of a number of arguments that prompted him to reject the existence of a vacuum. The homogeneous nature of an extended void space meant that every part must be identical to every other part. Because differentiable natural places could not exist in a homogeneous space, bodies would have no good reason for moving in one direction rather than another. They wouldn't have a medium, like that air carrying you forward. Natural motions would be impossible, and unnatural motions, because the external medium Aristotle deemed essential for violent motion would be absent. Bodies of different weights would necessarily fall in a void with equal velocities, which Aristotle regarded as an absurdity, because he thought they ought to fall with speeds directly proportional to their respective weights. Okay, so that's sublunar physics, and now we'll briefly cover the celestial region, incorruptible and changeless. So he's got one physics for the earth and another physics for the heavens, right? Aristotle regarded the celestial region as so incomparably superior to the terrestrial that he assigned to it properties that emphasize these profound differences. If incessant change was basic to the terrestrial region, then lack of change had to characterize the celestial region. Again, this is where his opposite thing. He seems to want to find opposites where they aren't there sometimes. Because the four simple elemental bodies moved with natural rectilinear upward and downward motion relative to the center of the earth, Aristotle concluded that the observed circular motion of the celestial bodies must necessarily be associated with a different kind of simple elemental body, a fifth element. Five. He should have known he was going wrong, going from 4 to 5. A fifth element, or ether. And to emphasize the special importance of the ether, he often called it the first body. Substantial change in the celestial sphere was impossible because Aristotle assumed that the pairs of opposites or contrary qualities, such as hotness and coldness, wetness and dryness, rare and dense, which were basic forces for change in the terrestrial region, were absent from the heavens and therefore played no role there. And because he rejected contrary qualities in the heavens, he denied the existence of lightness and heaviness, and so he concluded that the celestial ether could be neither light nor heavy. Lightness and heaviness in the terrestrial region were associated with upward and downward rectilinear motions, and the heavenly bodies weren't doing that. They were moving in circles, so different deal, right? So because planets and stars are observed to move around the sky, Aristotle inferred that change of position was the only kind of change possible in the heavens. Celestial bodies continually change their positions by moving around the sky with effortless, uniform, circular motion. Uniform circular motion in this case is a natural motion, just as rectilinear up and down motions in the terrestrial sphere are natural. But up and down are contrary terrestrial motions. Circular motion had no contrary. Aristotle concluded that circular motion, which lacked a contrary motion, was natural to bodies composed of celestial ether, which lacked contrary qualities. He thus assumed that celestial bodies neither approached the earth nor receded from it. Makes me wonder, I mean, even back then they must have seen, comets, things falling from the heavens. What did he make of that? Maybe he never saw one. You'd think he would have had reports. Anyway, okay, now, on the nature of the empty celestial spaces, here's where you get the spheres, okay? He said the celestial spaces were filled with invisible, transparent, ethereal spheres that were nested one within another, and each of which turned with regular uniform motion. Celestial bodies, excuse me, need some water. Celestial bodies, planets and fixed stars, were somehow embedded in these spheres and carried around by them. Okay. And give some background on that. Okay, so a momentous question was immediately posed then. What caused the orbs to move around with uniform circular motion as they carried the planets and stars? So you've got a sphere which the planets and stars are embedded in, and it's moving in a perfect circle, perfect uniform motion. But what causes it to move? So he gave two answers. In On the Heavens, he appealed to an internal principle of movement when he described the celestial ether as a simple body, naturally so constituted as to move in a circle in virtue of its own nature. But in his Physics and his other book, Metaphysics, Aristotle assumed that external spiritual movers, or intelligences, were the causative agents of the rotary motions of celestial orbs. So there's an angels of the spheres, something like that. So each physical orb had its own immaterial mover, which, although completely immobile, was eternally able to cause its assigned orb to move effortlessly around the earth with uniform circular motion. These immovable, or unmoved movers were unique in the world because they were capable of causing motion without themselves being in motion. Although Aristotle spoke of 55 unmoved movers to explain the different spheres that he was observing with planets and so forth, it gets more complicated. I skipped some of that complexity. Aristotle's concept of God focused on the unmoved mover associated with the sphere of the fixed stars, the outermost circumference of the world. So from Aristotle's point of view, you've got all these spheres within each other, right? And they're moving at different, they're each moving. And then the stars are fixed and everything else is moving within the outer sphere, which has the stars in it. And that's not moving. And that's where God is. For Aristotle, this most remote of unmoved movers was the prime mover, which enjoyed a special status as first among equals. I thought that was kind of interesting. How did an immaterial, unmoved mover cause a physical orb to move? I love this. It produces motion by being loved, was Aristotle's response. In the last, some people picked up on this. In the last line of the Divine Comedy, Dante speaks of the love that moves the sun and the other stars. And an anonymous French song proclaims, love, love makes the world go round. And Gilbert and Sullivan, in their operetta, say it's love that makes the world go round. Okay, anyway, I thought that was quite interesting. So now, what about the relationship between the heavens and the earth? So because he characterized the celestial ether as a divine and incorruptible substance, and viewed terrestrial matter as the source of incessant change by means of generation and corruption, Aristotle was convinced that the unchanging celestial region exercised a dominant influence on the always changing terrestrial region. It was fitting that a nobler and more perfect thing should influence a less noble and less perfect thing. Here also was a powerful reinforcement for traditional astrological belief, the influence of the stars on the earth. The various ways in which celestial dominance was affected exercised the minds of natural philosophers until the end of the 17th century, when the conception of the cosmos was radically altered. But throughout the Middle Ages, people are thinking about the influence of the heavens on the earth, which I feel like I remember there's a lot of that in Shakespeare. You see a lot of talk like that. I'm not a Shakespeare scholar, so I can't quote lines at you, but it just comes to mind. The model for celestial activity and influence on terrestrial affairs was undoubtedly the sun, whose influences were manifest and palpable. The sun's annual march around the ecliptic produced the seasons, which in turn produced various generations and corruptions. Human generation was also dependent on the sun, as evidenced by Aristotle's widely quoted assertion that man is begotten by man and by the sun as well. Okay, right. So that's all we're going to do of Aristotelian physics, I guess you could say. And but I think it forms an important basis as we continue and see how the medievals interacted with Aristotle. And in particular, there's a contrast between, Aristotle was not just the inheritance of the European Middle Ages. Aristotle had influenced the Muslim world. In fact, as we covered last time, many translations of Aristotle were out of the Arabic early on, because they had translated from the Greek, and so the Europeans got a hold of Arabic texts and translated from Arabic to Latin until they could get a hold of Greek texts. But the attitude toward Aristotle was subtly but really significantly different. They all respected him: the Byzantines, the Muslim world, and the Western Europe, western part of Europe, the former Western Roman Empire. Averroes, this is a Muslim scholar, paid Aristotle the highest possible tribute, declaring that Aristotle was a rule and exemplar which nature devised to show the final perfection of man. The teaching of Aristotle is the supreme truth, because his mind was the final expression of the human mind. Wherefore it has been well said that he was created and given to us by divine providence, that we might know all that is to be known. Let us praise God, who set this man apart from all others in perfection, and made him approach very near to the highest dignity humanity can attain. A historian of medieval philosophy said, "This is the most impressive eulogy ever given by one great philosopher to another." Indeed, Averroes considered Aristotle to be virtually infallible, because in his view, in over 1,000 years, no error had been detected in Aristotle's writings. Okay, so that's one view of Aristotle, right? Uncritical acceptance of what Aristotle wrote, I guess you could say. A complete devotion. Aristotle was greatly admired in the Latin West. Dante spoke for many when he described Aristotle as the master of them that know. Thomas Aquinas regarded Aristotle as someone who had attained the highest possible level of human thought without benefit of the Christian faith. And we might suppose, the author says, that with such reverential attitudes, medieval scholars would have sought to stay as close as possible to the great master. Disagreeing with Aristotle would be like this terrible thing. But they often moved away from him, not in the Byzantine or the Muslim world, but in the Latin West. And so in a later chapter, he's going to describe the manner in which Aristotle's medieval disciples and admirers altered and expanded his natural philosophy, even as they upheld its basic principles and remained faithful to its overall spirit. So they still considered themselves Aristotelians and working in an Aristotelian framework. And thinking, sort of coming at things the way Aristotle would come at them, but they did not feel that they had to stick with everything Aristotle said. They would find things that were inconsistent, places where Aristotle kind of didn't know where to go and just sort of gave up and stopped. And they would comment and say, well, let's see if we can do better than he did, standing on the shoulders of giants, as the show last time was called. So that is extremely key. I've read one explanation of why science only arose in the Latin West, despite other people have other civilizations, great civilizations, having Aristotle. And that is one of the reasons that was given. There's some others, but that's one of the reasons given, is that the Latin West did not take Aristotle as someone, as scripture, right? Scripture was scripture. Aristotle was Aristotle. Great respect for him, learned much from him, sat at his feet, but ultimately did not feel that he had the final word. Aristotle was a framework, a place to start, a giant to stand on the shoulders of, but he wasn't the end of the conversation. And the ongoing Aristotelian conversation, it is the purpose of this book and of this series, the ongoing Aristotelian conversation, which really got going in the Latin West, is what we now call science. And at its best, it just continues that conversation that Aristotle started. And that's why I titled the stream, Aristotle, the Father of Science. Okay, Froggy says this might be above my head. Yeah, mine too, man, Froggy. This is challenging stuff. Blotto says Aristotle may have just been snubbing his nose at Plato, who seemed to like groups of three. Okay. Oh, quintessence. I didn't know that. Okay, so quintessence. Oh, I see. I'd never thought about the root word. So quint is 5, the 5th essence. So quintessence is that 5th elemental type, the ether. And remember, it was the he also called it the first body. So we use quintessence to mean like the primary, the most important thing, right? That's very good. I didn't know that about quintessence. Okay. Apology to subscribers. I realize my credits really need to be updated. And I'm just going to make sure I'm not missing any super chats, and we'll wrap it up. Next week. Oh, there we go. Oh, yeah. I read that one from Froggy. Thank you. Next week, we'll be back with Black Horse, I believe. It should be, yeah. As far as I know, with more econ topics. We're quietly, sometimes we're not so quiet about it, but Black Horse and I are quietly feeling pretty proud of what we've done on the show, listening to Nicholas Solo on an interview with Russians with Attitude, and he's describing the failure of the Russian sanctions and the accomplishment of the Russians to not have the ruble fall apart. We talked about all of this about 1 month after the war in Ukraine started and explained what we thought would happen with the sanctions. We didn't think they would work. And what we already saw and thought would continue to happen with the ruble and why we thought these things. And keep on bringing that one up because it's called Ruble Stronk is the name of that episode. And feeling pretty proud of it. I realized I could be doing that. Yeah. So anyway, racking up some W's and enjoying that. Our goal is that we don't necessarily expect for the show to be a mass audience, but we're hoping, as Academic Agent would say, for it to be sort of a velvet underground, right? People with larger audiences maybe start to learn from us because we keep getting things right. So that's sort of our vision for that, for the Econ Mini show. So join us for that next week. And let's see. Oh, just events. I've mentioned them in other contexts, but there's an Old Glory Club event in Tennessee in early June. Would love to meet you there. I'll be there. I don't, as far as I know, don't think I will be at the UK event, but Skilding's just announced that. I shared it, so maybe I can tell you dates. If I can pull it up really fast. There we go. Save the date. August 30th to September 1st in the UK. There'll be an event there, Skilding's event. So go to Skilding's on Twitter, skildingsdot.com, would SCYLDINGS would get you there, or skildings.com/events, something like that. So anyway, some summer events, wanted to mention those in case you can get to those. I've been to one UK event, all the US events, and have really loved going. Brought my wife to the 2 US events we've had so far that Skildings did. It seems like, taking the time, paying the money, blah, blah, blah. But it is so important to get together in person, to meet people, to not feel alone and isolated. Really recommend it. Okay, so anyway, thanks for some great comments from folks, some of whom have actually studied philosophy, unlike me. I was literally borrowing my wife's philosophy book and grabbing a few things from there that I used because I never did a philosophy course. But anyway, I hope this was useful, and I think we're going to find that in continuing to understand what happened with modern, the beginnings of science in the Middle Ages, we're going to see how they are wrestling with what Aristotle did, thinking through it, amending it, and developing it, and getting us towards, science as we know it, right? Okay, so thanks everybody, and I will see you next week, and I'll update those credits, subscribers. I'll probably do that right after this. So sorry if your name's missing. I know I had at least one person join just this week, and I'll get your name up there for next time. Thanks, guys.